All right, so in the last video, we talked about the real numbers, and we sort of built them starting with the natural numbers. We looked at the integers, the rationals, and then the reals. Our main focus this semester is going to be functions of real numbers or real variables. Real variables just means that your variables represent real numbers. And so the good news for you is we're not going to look at complex numbers. We're not going to consider I or things like that. So you won't need to deal with 3 plus 2i in this course. If you were to solve x squared equals -1, we're going to say no real solution. If we write no solution, we mean no real valued solution, even though we know that this has a solution of x is plus or minus I. So we're not interested in that, in these kinds of solutions in this course. If you're interested in learning more about that, I would encourage you to take complex variables with us. We offer it occasionally, and the calculus is just absolutely fantastic over the complex numbers, but we're focusing over the real numbers. And so I want to remind you what a function even is. And so key sort of word that you should think about when you think about the word function, let's say a function, is a mapping. It's a mapping between sets. And so here's a classic example. If I have the set A, B, C, and I have another set 1, 2, 3, a function is just a mapping. It's an assignment from one set to the other. We're going to go this way. And so we might say, well, let's send A over here to 2, and let's send B up here to 1, and we'll send C to 3. And we could call this mapping, this relationship, the function f. And so the notation that we're interested in, several things, is the domain of f. That's the input set. And so for us, this would be the set A, B, C. And then we're going to talk about, in this course, we'll use the word range. The range of f, this is the output set, and this would be the set 1, 2, 3. All right? And then some notation that you've seen before. We want to be able to succinctly write where f sends, let's say, A. And so we'll say f of A equals 2, f of B equals 1, so on and so forth. And so this notation, you say f of, the parentheses you read is of, the inside, f of A is 2, is the same as really saying A gets sent to 2. That's it. So we'll use that notation all the time. So we're interested in functions of real numbers. And so what I want you to realize is that if you wanted to have a function of real numbers, you can draw a real number line here. Here's the reals. We'll start it at 0. And we could draw another real number line over here. And we could try to draw our function where you sort of map, okay, we're going to map that number to this number, and we're going to map this number to that number, and this number to this number. Well, that's really sort of difficult to make any sense of. It does work. You can do that. But what people typically do is they take this number line and they flip it sideways and they stand it vertically. So here's what we do. We go ahead and we write the standard x, y axis, which you've seen before, and let's do it like this. And hopefully my lines will straighten out here. That was really quick. There we go. So this we think about as the x-axis. You should think of it as the set of inputs. This is the input axis. And of course, we think of the vertical axis as the y-axis. And you should think of the y-axis as the output axis. We just took this axis and we spun it and we stood it up vertical, and we centered the 0 here on the 0 there. And so this allows us to visualize what's happening a lot easier. Now, if we want to have a function, and we want f of 1 to be 2, we go over here to find 1, and we put a dot up at 2, and that dot is telling you visually that f of 1 is 2. We send 1 up to 2. If we wanted to say f of 3 was 0, we could put a dot where the y value, right, the y value is the outside, the y value is 0, the x value, the input value is 3. And so we use this coordinate system to be able to visualize graphs like that. And so let's just do a quick example of a graph that you've seen before. So let's start maybe with f of x equals x squared. And so this is a formula. This is a function where the input is, you're told where the input goes by this formula. Whatever number that you want, call it x. When you plug that number into f assigns it to x times x, to x squared. So this is sort of a formula for your function. And you can actually run some numbers. You can say, okay, so f of 1 is 1 squared is 1. F of 0 is 0 squared is 0. F of 2 is 2 squared is 4. F of negative 3 is negative 3 all squared, which is 9, so on and so forth. And at this point, you can graph this thing. Now, what I want us to realize quickly is that you can always, if you want, plot points. I can plot 0, 0, 0 goes to 0, 1 goes to, whoops, yeah, that works. 1 goes to 1. Let's actually, just for the sake of clarity, let's line those axes up where they're actually falling on one of these dotted lines. There we go. All right, so 0 goes to 0, 1 goes to 1, 2 goes to 4, so on and so forth. But what happens is, at some point, you're going to just fill in the missing points. You can't possibly graph them all by hand. And so we actually write down the graph of the function and say that that's more or less it. This is a hand sketch. And what's happening is this visual image, this little sketch, is showing you the way this function actually behaves. If you want to know where does it send 1, 2, 3, it sends 3 up to this y value. Well, my function is not to scale because I've got it at 1, 2, 3, 4, 5, 6. It should be up here at 9, so I should have gone quite a bit higher actually, but it's okay. This function is showing you where each x value is getting sent to. So we talk about the graph of a function, we're talking about this. All right, well, let's end this video here, and we'll continue in the next.